Well, thank you very much, everyone, after sitting for 2 hours. This is the first of our specific topic-focused events, and it's a great pleasure to welcome everybody here. This session is dedicated to Erna Yackel, whom I did know, and there will be people here who knew Erna even better, but part of a trio, if I can say, Erna Yackel, Paul Cobb and Terry Wood. Over to our first presenter.
Thank you, Max. I guess I and the other presenters are delighted so many of you came. For us, it's an honour and a privilege to get to talk about the work of our friend and dear colleague, Erna Yackel. I'm going to be talking about the early phase of Erna's career. As Max said, during this phase, Erna collaborated with Terry Wood and with myself. I worked with her very closely from 1986 to 1999, and then, of course, we kept in touch through the years after that. The goal of that collaboration, when we started back in 1986, was very simple: to investigate how to support students' attainment of what we would term rigorous learning goals in mathematics. And by, at least in the US context, when we talk about rigorous learning goals, we meant that students would develop, yes, procedural fluency, not just procedural competency, and conceptual understanding, problem-solving capabilities, and central to Erna's work, to explaining and justify their mathematical reasoning. And you'll hear a lot about her work in that area as we go along. Two of the major contributions of this first phase of the work in which she was involved were the development of the notion of classroom social norms in math classrooms, and particularly the notion which she's probably most associated with, socio-mathematical norms. And that's what I will quickly talk about, starting with social norms. To set the context, 1986, when we began working together, the three of us conducted a year-long classroom teaching experiment. We now call it a classroom design experiment or a classroom design study. The classroom teacher was a full member of our research team who was in all of the meetings when we made decisions and so forth. And it was in a second grade class in the US, so 7 to 8-year-old students. We had initially in fact planned to work in that classroom just for 3 or 4 months. And then at the end of that period, the teacher said, "Now what am I going to do? You can't leave." And that's why it ended up being a full 1-year classroom design study. In addition to developing the materials, working with the teacher on figuring out instructional strategies, we videoed every classroom lesson. So we ended up with a heck of a lot of data at the end. The lesson structure was new to the teacher, to the students, in a sense to us, which was the teacher would introduce mathematical tasks so that kids understood what the task was asking them mathematically, so they understood the context of the task, but without hinting about how they should solve it, which is a non-trivial feat. The students worked on the tasks in pairs, and then the teacher led a discussion at the end in which they were expected and supported to explain and justify their reasoning. Now, with regard to social norms, I said what our agenda was, which was to focus, and I assumed that we were just going to be analysing kids' reasoning and how it evolved in the context of instruction. That was derailed within the first week, because of what we saw the teacher doing. In particular, she initiated what we later came to call the renegotiation of classroom social norms. And here's an incident just from the very second day, the second lesson of the entire school year. I remember this so vividly. This kid comes up to the front of the classroom to explain how he solved a task. This is a very new, totally novel to the kids. And halfway through, he realizes he's made a mistake. And he literally says, "I've made a mistake," puts his head in his hands and turns with his back to the rest of the class. The teacher takes over and she says, "That's okay, Peter. It's all right. Boys and girls, even if your answer's not correct, I'm most interested in having you think." So notice the teacher is telling them what in this classroom is going to be valued. She goes on, that's the important part, the thinking part. We're not always going to get right answers, but we want to try. So it's this idea of sharing our thinking, sharing our reasoning, if figuring out what if we've made a mistake, why we've made a mistake, that sort of thing. And we talked about such incidents as that they're now shifting from doing math and talking math, how we solve tasks, to going up a meta level and in effect cutting out and making as a topic of conversation something's just happened as they were doing math together. But we called it talking about math. And we went through and analysed all of those incidents, of which there were a heck of a lot. And that became the focus of the first analyses that we did. And in terms of doing that, we identified a set of classroom social norms, persisting to solve challenging tasks. You saw that in the little clip I showed you, explaining and justifying reasoning. For the listening kids, there's also obligations here to try and make sense of others' explanations. Very important to indicate understanding and non-understanding. Here, it's valued if kids tell you they don't understand. That's valuable information for the teacher, right? To adjust instruction, indicate agreement and disagreement. Ask questions when you don't, particularly when you don't understand, and raise challenges if you disagree, and explain why you disagree. So those were some of the social norms. That first part of the work, I would say the three of us did that together. We had to figure out how do you analyze all of these data across a school year and so on. That was the focus of that work. And in doing that, we felt we were learning something that was worth knowing. However, at some point, the penny dropped in that these norms are not specific to math classes, right? We can imagine similar sorts of norms being established in geography classes, in science classes, and so forth. And it's at this point, the second major contribution, which Erna initiated again. As background, by this point, she had moved, this is 3 years later, to another campus of our university, which was Purdue University. And she conducted, by herself, with a couple of other people, a follow-up teaching experiment in another second grade classroom with another teacher. And it so happened that this teacher routinely asked the students if they'd solved it a different way. So a kid comes up and explains the solution, and they do it a different way. And Erna became fascinated with these little interactions as they were negotiating what counted as a different way in the classroom. And so she identified them all and analysed them all. And she invited me to work with her on this. And I remember how excited she was. And she would bring out examples of the same kids when they were working in small groups at different points in the school year. And you could see changes in what counted as a different solution and so forth. The first norm she analysed, and she didn't just analyse the norm, she analysed how it was negotiated in the classroom, was what counts as a different mathematical solution in this task room. What counts as an acceptable mathematical explanation in this classroom? What counts as an insightful mathematical solution? The key point to note is that these norms are specific to mathematical classrooms. And not only that, they're specific to a particular view of what's worth knowing and doing mathematically, a conceptually oriented view. So, social norm, students are obliged to explain their reasoning. Applies to all classrooms. Corresponding socio-mathematical norm specifies the criteria for what counts as an acceptable mathematical explanation in this classroom. And in the case of the classroom that Erna analysed, its students were expected to explain, not by telling you, I did this, I did that, I did this. They were expected to explain in terms of actions on quantities, or crudely put, amounts of stuff. They were actually speaking as though they were operating in a mathematical reality, a quantitative reality. Now, that's the sort of quick flyby of the very early years of Erna's career. There's a lot more to come, as you'll hear from my colleagues in a moment. But stepping back, it's absolutely no exaggeration to say that Erna's work continues to influence how researchers analyse teachers and students' actions and interactions in math classrooms. I happened to look up this morning the original paper where we first wrote about socio-mathematical norms. Erna's the first author, and quite rightly so. That's been referenced 3,600 times so far, and it's continuing to be heavily referenced year after year. Why do I think that's the case? On the one hand, it has an explanatory power. It helps us make better sense of what's happening in classrooms, but it also has pragmatic implications. It indicates specific norms it's important for teachers to establish in classrooms if you value conceptual understanding, mathematical communication, and so forth. Something else I want to highlight, and this is where my virtual Erna clicks in. We were talking about that earlier. Erna would be very upset indeed if we didn't acknowledge the contributions of the teachers we work with. The teacher in that first design study, her name was Grace Ann Merkel. She was a very experienced primary school teacher when we worked with her. And she had a remarkable feel for social relations in the classroom. As you saw from that tiny lecture, that was classic Grace Ann. She understood that if she wanted kids to explain and justify, she had to create a very safe environment. And she knew how to do it. So we were very fortunate to work with Grace Ann. It's very unlikely we would have, who knows, but working with her, we lucked out completely, as Diana has informed me numerous times. The second teacher Erna worked with was Mr. Willie Mack King Jr. He had a really sophisticated mathematical knowledge for teaching. He was very adept at recognizing the mathematical possibilities in his students' classroom instructions. And Erna has told me very explicitly, she doubts that this whole idea and notion of socio-mathematical norms would emerge had she worked with a different teacher. So they, in their own way, are sort of unacknowledged contributors to this work. And lastly, I just want to point out something I think it's worth you knowing about Erna's career trajectory. She didn't complete her doctorate in math education until she was in her late 40s. She got initially a master's degree and an undergraduate degree in mathematics, and then stepped away from academia for a number of years to focus on her family. And only when her kids were old enough did she come back and begin doctoral studies. And I met her shortly after she finished those studies. Something else to note, 6 years after she completed her doctorate, she became the first researcher in education, not math education, but education, to get a National Science Foundation Presidential Young Investigator Award in the US. This is highly prestigious, and it's also worth having. It came with a lot of money that Erna could use over a 5-year period to support her research. All the previous awardees have been researchers in mathematics, in science, or in engineering. And not surprisingly, after she won this award, they renamed it. They call it the Early Career Award. I've got some time left, which is shocking for me. So I want to tell you one more thing about Erna then, off the cuff. Something that I think people don't know about. That classroom where she worked when she did with Mr. King, he's called Mr. King for a reason. It was an African-American community, and in that community, with the history of race in the United States, there were very limited job opportunities, career possibilities for somebody like Mr. King when he was coming up. He was a middle-aged man, an African-American man when Erna worked with him. And so within that community, teachers were always Mr. or Mrs. or Miss. It was an honorific, like we would have, say, doctor or something. The students in that school, in the district where she worked, were basically 100% African-American, as were most of the teachers and all of the administrators. Erna intentionally decided to work there because she saw the need, not these poor little black kids, but because of how under-resourced the district was. Erna was the sort of person who would never make a big deal about that. She wasn't interested in polishing her liberal credentials, and I will say we see so much of that nowadays. She was interested in figuring stuff out that was actually relevant to all kids. And I think her work in that district is a really great example of how working in a situation or whatever that happens to, where the students are from particular quote, minority groups, can have implications for numerous, basically in this case, all other groups of students. Now I'm going to hand over to Michelle and then for Chris, who are going to talk about Erna's work on mathematical argumentation.
Thank you.
Hi everyone, I'm Michelle. I had the privilege of working with Erna and my first job out of my doctoral programs. And so in that way, she was an academic mentor, a personal mentor, and just frankly a friend of mine. And so I really feel privileged to be here. So Paul has already talked quite a bit about her major contributions to the notions of social and social mathematical norms. And indeed, that's a huge contribution, but you may not know that that contribution came from her more broad interest in just mathematical argumentation in general. And her research program was really about trying to understand students' and teachers' explanations and justifications in mathematics classrooms. And so for Erna, when a student or a teacher explained, the reason a person explained in those classrooms it served to clarify one's mathematical reasoning. But that was distinct from what she said a justification would be. Those are further elaborations that result from either actual or perceived challenges to one's explanations. And so she made that distinction. Erna was interested in studying the structure and the function of students' contributions to those informal classroom, you might say organic mathematical discussions that come about in a classroom kind of organically. That doesn't mean she wasn't interested in the more formal proof and argumentation, and she did write a little bit about that, but her main research program was in those organic classroom discussions and how people were contributing to those discussions and what mathematics became understood through those discussions. And so in the 1990s and early 2000s, she worked with a German researcher, you may know Götz Krimheuer, and Götz was working on, he had found Toulmin's work in argumentation. And that's a general constructs to try to understand when people make contributions to make an argument, what is the function of the words that they say in an argument, and he tried to detail that. And that was a general kind of set of constructs. And Erna and Götz started thinking about utilizing Toulmin's model of argumentation to analyze the purposes of students' contributions in math classrooms. Oh wow, it just really went, didn't it?
Yeah.
So to give you an example of what that is, I borrowed an excerpt from Erna's 2001 plenary at PME, and she presented this very example. And if you will, the left-hand side, the yellow, is the problem that these primary kids were solving. The teacher had posed this problem. Take 10 seconds, 5 seconds to figure it out. You probably got it now. And so the example in the plenary address was between one student, Lewis, and a teacher. And so Lewis gives this contribution. He says, it's 24. How I got it was I said 48, 58, 68, 69, 70, 71, 72. And Erna, using Toulmin's model of argumentation, would analyze those two sentences by Lewis. And she said, according to Toulmin, Lewis is making a claim. He's making a conclusion. It's 24. And then, so that's one function of argument, is to make a claim. And then he elaborated and gave data for how he got that answer, that claim.
Sorry.
It's okay. There we go. So how the claim, that evidence for that claim of 24. Now, for a lot of students, the number sequence that Lewis says here, it's not clear how that number sequence leads to 24 at this point. And so from Erna's perspective in her analysis, she sees the next move by the teacher as calling for what Toulmin would call a warrant. How does this data relate to 24? How does this number counting sequence relate to 24? And so you see the teacher say, you said 48, 58, how many is that? Lewis says 10, and the teacher says, and then you went to 68, and how many was that? Lewis says 20, and then the teacher says, well, that was 20 in all, and then you went by ones, didn't you? You went 69, 70, 71, 72. So you went a 10 and another 10 and 4 ones, and that's how you got 24. And as she's stating this, she's recording Lewis's thinking on an empty number line, which you may be familiar with if you've studied Erna's work. And so from that perspective, the data from Lewis, you may see on the bottom of the empty number line, and then the warrant that's interactively constituted between Lewis and the teacher is there on the top of the empty number line. And so in that way, the empty number line becomes sort of a part of the argumentation as well. And then the teacher, she says, Erna says, realizes that about half the students don't really understand or don't know at hand that from 48 to 58 is actually 10, because it's early on in the school year. And so recognizing that, the teacher says, okay, we need something that's called a backing, the validity, the mathematical validity of going by 10. And so she asks, she points to the number line, and so she calls for a backing here, and she points there and she says, okay, how did you know that 48 to 58 was 10? And Lewis says, I just knew it, but you can do this, and he counts on his fingers. Okay, we're going real fast here. So what Erna started to do, and I started to learn from Erna, was that she would kind of draw up an argumentation scheme that looked something like this, and she would put in the contributions from the students, and that would be this function of each of the contributions that Lewis and the teacher were making here. And you can see the empty number line inscription there as part of the warrant. Now this is an argumentation between Lewis and the teacher, one student and a teacher. And we all know, and Erna knew, that classroom argumentation was way more complex than that. You've got a lot of students in the classroom. And so what she would look for is, there's a claim of 24 being made, and there could be, if it's a teacher that asks for different solution methods, you might see 2 or 3 or 4 different data for the same exact claim. And I'm not going to go into detail about this, but you might even see more warrants for these, because you have more data being given by more students, and you might have backings coming out. And so it got more complex, and sometimes you would have claims that would be, from our perspective, an erroneous claim that a student would, where are we? No, too fast. That a student would give data for as well, and then you might have discussion. And again, there's constructs to kind of understand the function of all of these contributions. And so that's what Erna was really interested in doing, is creating these argumentation schemes to understand the role that contributions were making in what was becoming what we might call taken as shared mathematical ideas in the classroom. Those ideas that are beyond justification now. We all kind of take it as a given that we agree that this is true, and we don't have to justify it anymore. And so Erna took it another step further. So she actually started thinking about it from a researcher's point of view as a methodological tool now. And she says, okay, if I look across several days where they're problem solving like this, do I notice something about the contributions that students are making? What's happening here? And what she noticed, and really contributed to my work and my dissertation work actually, was she started noticing that eventually these backings started dropping out. It was no longer necessary to provide that mathematical validity. So that meant for her, whatever was in that backing had become taken as shared mathematical idea. You no longer had to justify that from a decade to another is 10 things, a quantity of 10. She also noticed that warrants might fall out as well. And when those were dropping out after a while, whatever was in the warrant she could consider taking as shared as well, mathematical idea. And in this case, it would be something like reasoning flexibly and mentally with numbers and sums and differences with numbers up to 100. So she started doing that. That's what I learned from my work with Erna. What we did, a few researchers, Chris will talk about it as well, and other researchers have done since Erna's methodological work is, we started looking at our own argumentations in our own classrooms, differential equations, integers, 7th grade, and looking at the discourse there and trying to understand the mathematical ideas that have become taken as shared in those classrooms as well over time, and using her technique. And what we found was, that sometimes, let me go back to this. Sometimes what might be in an argument where data or the warrants and backings fell off, so something that had become taken as shared in a previous argument, sometimes that claim from a previous argument or a data or a warrant from a different argument started becoming data for a new claim. And from our perspective, that's another sign that a mathematical idea has become taken as shared. And Chris is going to share some more of her influence on our work.
Thanks, Michelle. I'm Chris, and I also, like Michelle, had the honor and privilege of working with Erna when I was a fresh green academic out of doctoral school, and Erna was an extreme mentor for me in a most positive way. So I want to say a little bit about her pioneering work in argumentation, specifically as it relates to undergraduate mathematics. So her work with Paul started in second grade classrooms, and you can see the generativity of the ideas transferring all the way up through tertiary mathematics. His work has been very influential in tracing argumentation in inquiry-oriented classes in differential equations, linear algebra, math content courses for future elementary and secondary school students. It's also been influential in physical chemistry. So you might think about the notions of argumentation. If they're inquiry-oriented classrooms, they apply to not just mathematics, but also to chemistry, biology, physics, etc. So we've seen the generativity and power of Erna's work across content. It's also been generative for new research. So one of the things that I think is pretty interesting, Michelle talked about the way in which Warren and data might drop off as ideas become taken as shared. Researchers have also identified that certain gestures drop off as ideas become taken as shared. In that case, it's really interesting to put in the embodied cognition aspect of the collective argumentation. There's also been some work by researchers to coordinate this methodology for documenting the collective production of understanding in a classroom setting with individual cognitive constructions. In particular, the work by Tommy Dreyfus and Vina Hershkovitz in the abstraction and context, and their epistemic actions of recognizing, building with, constructing, and consolidating. And so these researchers have coordinated the criteria that Erna started to identify their ideas become function taken as shared with the individual constructive activities. I also want to mention a third criteria that emerged from Erna's pioneering work, and that's when the same idea is used multiple times to justify different claims. So I'll give a diagram for that in a second. So imagine you have, and this comes out of work in physical chemistry class. So imagine there's a particular idea in physical chemistry where the relative motion of solids, liquids, and gases are different. And so using that as a data point to make claim 1. Using that same idea to make as data for claim 2, and then the same idea for claim 3. And so that's empirical evidence that this idea of the relative motion of particles is a truth within this physical chemistry class. Because we see it's being leveraged over and over again for different claims. There's also, returning to Paul's discussion around social mathematical norm, how that's also been useful across undergraduate science and math classrooms. It's in physics, in chemistry, in undergraduate mathematics. So the generativity of Erna's work is phenomenal. I don't know many researchers that have this kind of impact decades after the initial work. And with that, I didn't even get a time. That's awesome.
Oh, there you go.
1, perfect. And so I'm going to turn it over to Diana now for the next part.
Okay. My name is Diane Underwood. I started working with Erna when I was 22 years old, I believe. And I worked with her until a couple of weeks before she died. So let's give this a go. Paul, Michelle, and Chris have described Erna's contributions to the theoretical constructs of social norms, socio-mathematical norms, argumentation. This work happened while Erna was on the faculty at Purdue University Calumet. While Erna's work with teachers is very well known to the teachers in our area, they're not so well known to others until now. Teachers change for 2 reasons. They either see the light or they feel the heat. Erna was all about helping teachers see the light. Erna spent thousands of hours conducting professional development workshops and teaching master's level courses for pre-service and in-service teachers. But those opportunities had a deep impact on the way future teachers and practicing teachers viewed mathematics teaching and learning. As Erna's graduate assistant, I grew up in those workshops. And in working with Erna as she worked with teachers, there were thousands of incidents where she helped, but teachers saw the light. But what comes after seeing the light? For teachers such as Debbie Herndon, as we see here and we'll see in our videos, it meant a whole new way of thinking about teaching and learning, but it also meant she knew that she didn't know all that she wanted to know to teach mathematics to her first graders. She was not the only ones she was not the only one that felt that way. You see. When Erna retired from the university, she was asked by a group of 5 K-12 teachers who had attended one of her summer institutes to help them in their classrooms as they implemented an inquiry approach to instruction and her inquiry sequences. Every week, Erna would observe each teacher's math lesson. After the lesson, Erna would write a detailed 4 to 6 single-spaced reflection on each lesson, which she would then send to the teachers. Erna thought deeply about what she was going to put in those reflections before emailing them off to teachers. She knew that tone could be easily misinterpreted in an email. She would talk to her husband Jim and say, take a look at this, or she'd send one to me and ask about the tone to make sure that it wasn't interpreted as feeling the heat. In all, Erna observed 272 lesson observations over a 4-year period. And she wrote 272 of those 4 to 6 page single-space reflections. Whenever it was possible to do so, the reflections focused on a particular child or children and how they interpreted a task, or how they might have interpreted the classroom interactions and how those interactions might influence the learning opportunities. But why did she focus on the learner? Why not the teacher? Focusing on what the teacher did or didn't do could be problematic. First of all, it's a really good way to irritate teachers. And it can be interpreted more like turning up the heat. Teachers who are trying to reconsider their practices, especially new teachers, are already hyper-focused on what they are doing. Erna's goal was to help teachers become more attuned to listening and reflecting on students' actions and how their actions are related to the students' learning opportunities. Erna described her approach as helping teachers to notice. Erna drew upon her work with Paul and others, and it was influenced by John Mason's work on the discipline of noticing. As Erna said, the teacher must be able to notice things of potential significance in the classroom other than her own actions. One way we are sensitized to noticing is when someone else calls to our attention and prompts us to think about students' activity in a way we had not previously considered. So, how can we provide opportunities for noticing? What are the significant things that can come out of making those observations? Well, at one point after Erna retired, and Kuno Gravemeyer, which I know a lot of you probably know Kuno, he had asked Erna to contribute a paper to a journal describing her work with teachers. At first, Erna wasn't sure she had anything to contribute because she wasn't doing research. But she took on the task anyway to describe her work with teachers. She sorted through those 272 reflections. Even she was surprised about how many reflections she had written. And in the end, the reflections fell into 4 different themes. They were instructional design and activities, participation in discourse, analysis of student solutions during the lesson, and notation and its impact on students' learning opportunities. As I'm sure you can see, that these themes are deeply rooted in Erna's earlier research. So the question becomes, how do we engage teachers in noticing when it's not really all that feasible for us to all be there all the time to help them notice? So, at one point, Erna said to me, "We should write a book." And I said, "I don't want to write a book." I said, "Let's do something different than writing a book." Now, the reason why I said that is I'd been, since I was like 22 years old, I'd been in all those workshops with Erna. And I knew that that's not a static experience. that has to be something other than a book. And so we decided to do something that neither one of us had any idea how to do. And we decided we're going to make some videos. So we made a website and we've made some videos. So the purpose of the website, and there's a QR code if you want to scan that. Okay, I'll put it at the end too if you don't get a chance to get that. The purpose of the website was to provide mathematics teacher educators and coaches with videos and notes to support the development of inquiry mathematics classrooms. The content focuses on early number concepts through two-digit addition and subtraction. The instructional sequences and approaches were first developed in typical American classroom, as Paul has described, with Paul and Erna and Kuno Gravemeyer and a host of graduate students helping out. Let me see if this is going to work now. I was going to show you the video, but you know how things work. We're going to just show you. I made a little video of the website so we can see that. So things are going to pop up here. There are several RME instructional sequences, patternings and partitionings. Those are for numbers under 10, structuring numbers, coordinating units, measurement, the teacher's role. If you look at like one of the first bits, it's patterning and partitioning. It starts out with a description of the instructional sequence, and then the videos come up with instructional activities. And eventually, as it scrolls downward, we get to a section where there's a suggested timeline and instructional materials for the teachers. These videos are very dense. For example, just the video on finger patterns alone, the running time is 31 minutes and 45 seconds. These are not designed to be the 5-minute videos that one would just give a teacher or point a teacher in that direction. These were designed to be used by a mathematics teacher educator in their work with teachers. Erna put everything into the videos. Everything is in there that she would possibly have thought of. It's in the videos and in the material. So I say that because they are very deep, and I hope you take a look at them. But I do want to give you a little bit of a flavor of what one of those videos looks like. And if I go to this page, whoops. This video in particular, it was called The Teacher's Role, and it was on orchestrating productive class discussions. Okay. The purpose of this video is to illustrate how the teacher's questions function to promote an effective discussion. I hate it when that happens. The context for this video is a whole class activity in which children figure out the total number of beads on an arithmetic rack. Are you all familiar with an arithmetic rack? Raise your hand if you're familiar with an arithmetic. Raise your hand if you're not familiar with an arithmetic rack. There you go, good. All right, an arithmetic rack looks like this structure up here. Let me go back a page. There is a rod with 10 beads on top, 5 white, 5 red, and 10 beads on the bottom rod, 5 whites, 5 red. The beads can be moved back and forth, and all the children in the class had access to an arithmetic rack when it was needed. When this arithmetic rack is used within a robust instructional sequence like the one Erna put together, it's on our website, children develop thinking and grouping strategies for adding and subtracting numbers under 20. Now, let me give you a little bit, there's a little vignette we're going to do. The setting of this vignette is in a classroom. Here, all the children, as you can see, have an arithmetic rack, and the teacher projects, boy, this thing is not doing what it's supposed to do, is it? So, the teacher says to the class, make your rack look like mine. So the children can move the beads, and she asks how many people are on the bus. So just to let you know ahead of time, the students all know that they're supposed to be reading the number of beads on the left side of the arithmetic rack. That's already been established. The students, this was all figured out earlier in a lesson. When we ask how many people are on the bus, it's because the context underlying this was a double-decker bus, and the way the bus driver kept track of the people on the bus is with the top rung were the people on the top of the bus, and on the bottom rung was the people on the bottom deck of the bus. So the teacher does not pose questions and tasks that the students are already expected to know the answers to. That's what the idea of the class instruction is. Students are expected to figure out the answer to the questions or solve the task in ways that make sense to them. So, oh, another kid popped in. He was late, missed the bus. So, after giving them a bit of time, the teacher calls on several children. Roberto, 15. Sammy, 14. Tanisha, 15. Marco, 15. Paris, 15. This is what we would call, after this, we would call this a light bulb moment if you were working with teachers. Oh, forgot about Carla. Sorry, Carla. Carla, 15. So we would call this a light bulb moment. So it would be a place where teacher educators would want to stop and say, why does the teacher call on several students for their answers? In this case, the teacher calls on several students first before asking for their explanations, giving them the opportunity to think about the other answers that she's going to get. So she eventually calls on Sammy, who had the answer 14. So, Sammy, how did you figure out 14? And Sammy says, I saw 7 on the top and I counted 7, 8, 9, 10, 11, 12, 13, 14. To which the teacher replies, does anyone have a question for Sammy? So this is also another one of those moments where you'd want to ask, why does the teacher call on the student with the wrong answer? Well, this is another light bulb moment. The teacher opens up the discussion by asking, does anyone have a question or a comment? And, as we find out later, wrong answers are treated the same way as correct answers in this class. As the dialogue continued, the teacher asked the next question is, who figured it out like Sammy? Did anyone have a different way of figuring this out? The teacher's questions shift the discussion away from the children's answers to their solution methods. And we see this child pop in called Leon. Leon, I counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And the teacher says, thank you, Leon. Leon counted to figure this out. Did anyone use the color groupings of the beads to figure this out? This is another light bulb moment. You know, why did the teacher do this? Their students learn to recognize different solution methods that we can see from Leon's solution. But we can also notice that teachers can acknowledge a student's counting-based solutions and keep focusing on grouping-based solutions. It is so easy, so typical for new teachers who are coming to think about an inquiry approach, is to just gather solutions instead of trying to figure out which ones they're going to lift up. And this video is trying to help teachers make that leap to knowing what their role is too. But I want to show you what continues, and this is with Erna's words.
The dialogue continues. Paris says, I know that 10 and 5 make 15. And the teacher asks, does anyone have a question or comment for Paris? Notice that the teacher's question here is exactly the same as the question she asked earlier in the dialogue after Sammy gave his solution. Her purpose is to get others involved in the discussion. The most obvious question to ask Paris is, where did the 10 and the 5 come from? It is significant that the teacher refrained from asking this question herself. She did so because she knows that other children in the class are surely wondering the same thing. So instead of asking that question, she invited others to ask questions or make comments. The dialogue continues.
Oops, sorry about that. As the dialogue continues, the teacher asks additional questions and the students respond to those. I just wanted to point out some of the questions that were asked. She asks, does anyone have a different way of figuring this out? Does anyone have a question or a comment for Paris? Can you help us understand how Paris figured this out? What do you understand about what she said? Zane, can you help us understand how Paris figured this out? And is Paris's way the same as or different from Sammy's way? Now, if we look back, how are they different? When we look back at the beginning, what Erna found out from those reflections, we look at, it says instructional design and participation in discourse. This video is really focusing on participation in discourse. And the questions that were asked really help us understand how the teacher decides who to call on, ways the teacher engages everyone in the discussion, how the teacher encourages students to try and understand and make sense of students' thinking, and how she knows what they understand. The teacher techniques that establish that students are expected to listen to each other and attempt to make sense of each other's reasoning make it possible for all students to advance. This is really important. Erna wanted to follow this up, and this is what she says.
As students listen to each other and attempt to make sense of what others say, they inevitably interpret what they hear in terms of what they currently understand. And when children hear something that is within or just at the boundaries of their current understandings, they are often able to make sense of it and incorporate that thinking into their own. In this way, through participating in the discussion, even as listeners, students are able to advance to new levels of understanding.
I'll talk a little bit about Erna's legacy. When Erna passed away, at her memorial service, we just asked teachers if they wanted to share anything about what they had learned from Erna. And we had a lot of people that were very eager to explain, to say what they felt. This is one of the comments from one of the teachers. Erna Yackel forever changed the way I interact with students in mathematics. Her work showed me how to listen to students and give all students an opportunity to explore and demonstrate their understanding in a safe environment. Encouraging discussion and interaction among young students is not always easy, but by participating in classes and professional development that was inspired by her research, I learned to take the time needed to give every student a chance to join the mathematics conversation. Math is still one of my favorite subjects to teach. Erna changed the lives of hundreds of teachers. The video and the notes are an attempt to provide others with a way to continue that work. Our hope is that you will be able to share this video and the rest of the videos in the series with primary grade teachers. Thank you.
Thank you, everyone. I just have a very small part here. I've been asked to actually draw the threads together here. And I think the purpose of this presentation has been to highlight Erna's contributions to mathematics education in a lot of different fields and contexts. Many of you will know her work, but many of you might only know it in one particular context. And even as we were planning this presentation, the speakers found that they didn't know everything that Erna had done. And she had such a huge body of work that we had to be very selective. And really we wanted to focus on the implications for future research and practice and trace a trajectory, revealing how each phase actually built on a previous one and also indicate how her work can be continued. So the early classroom experiments that Paul talked about was really a collaboration between teachers and researchers, something that's really important so that the research and the practice are drawn together and feed into one another, and the results of research actually make a difference in practice. And as Paul pointed out, the aim was to create an inquiry approach, teaching mathematics through problem solving and children acting as mathematicians. And as part of that work, the researchers developed the construct of socio-mathematical norms as opposed to just social norms. And that was done together with the teachers and the experiencers. I was very lucky that in 1994, I was able to spend 6 weeks living and working with Erna, living with Erna and her husband Jim, who was then the president of the Calumet campus at Purdue University, and living in the premises there. And every day, pretty much, Erna and Diana and I went out to visit the grade 2 classroom that Paul had referred to and saw the instructional sequences in practice using the bead strings and the empty number line. And also, though, even more importantly for me, seeing the children's use of argumentation in practice. And this has had a really big influence in my research since then. And that's a long time ago, 1994, just a mere 30 years. and also seeing how this idea of the ideas being taken as shared, as Michelle has talked about. So the impact of Erna's work, there's been widespread adoption of the theoretical models of socio-mathematical norms and argumentation. As Paul pointed out, that seminal paper, I think he said, had 3,600 and something citations. But also the use, as Michelle and Chris talked about, the use of socio-mathematical norms to actually, as a tool of analysis. And I remember Michelle talking about this, I think in 1998 at PME. Yes, and I remember her talk very well from that because she used it as a tool for analysing what the children had learned over the period of 6 months or a year, I'm not sure which, by looking to see which of the claims no longer needed the backing because they were taken as shared. And there's a lot of resonance between this work and a lot of other work that's being done elsewhere. For me, it's with the Japanese structured problem-solving approach, which I've been very, very interested in for also almost 30 years. And when you look at the so-called Neriage phase of the structured problem-solving lessons, where the teacher gets different students to explain their solutions and draws on that, and I think it really resonates very strongly with me. And the thing that is really so good in those videos is it unpacks what the teachers need to do. These videos that Diana's been showing us, it unpacks what the teachers need to do to orchestrate that sort of discussion. And that is really, really hard. And that's what people find really difficult. So I think that those videos, we've seen Erna's observations and extensive reflections on teachers' lessons, but the series of videos, to me, really capture Erna's early classroom experiments. They're animated in the most beautiful way, and most of them have Erna's voice on them, and they are just wonderful. And they show both instructional sequences for the early years, but they are equally, the videos about conducting productive whole class discussions are relevant across all the years, I think. And if I was still teaching undergraduates in mathematics education, I would certainly be using these videos. When Diana showed them to me at first, I said, you've got to show them to prospective teachers. So thank you for that.
Yes, June.
Yes.
I stuck it in the end.
Yes, so that's from Diana. But also, I think we have about 3 minutes for questions, but all the speakers have said they're happy to hang around for a while if people want to ask more questions.